Kia ora team, this is Mr. Dama, and today I want to talk to you about stationary points. Stationary points of a function are where the function has a gradient of 0. So let's consider the function f of x is equal to x squared plus 6x. We're going to have a look at where the gradient is 0. So to do that, we must differentiate. So multiply by the power, take 1 off the power, multiply by the power, take 1 off the power. Let's have a look at where the gradient is 0. 0 equals 2x plus 6, so 2x is equal to negative 6, and x is equal to negative 6 divided by 2, or x is equal to negative 3. This is where there is a stationary point. And we can look at this graphically as the point where the gradient is 0, or the equation is flat. But this is not the only type of stationary point. Let's look at another example. If I had f of x is equal to x cubed, f dashed of x is equal to 3x squared. If I were to find out where the gradient is 0 and solve for x, you'd notice that x was equal to 0. But it doesn't look like this turning point. Let's draw this. A cubic kind of looks like this, where at this point x equals 0, there is a stationary point. But it's where the gradient is flat, but it's also not a turning point. This point specifically is called a point of inflection. So, there are two types of stationary points: turning points or not turning points. We are going to look a lot more at the turning points kind of stationary points, because if you find the stationary point, you can determine whether it's a local minimum or a maximum. Let's have a look at this function. F of x is equal to x cubed minus 9x squared plus 24x. Let's find the stationary points of this function. To do this, we must differentiate. Multiply by the power, take 1 off the power, multiply by the power, take 1 off the power, multiply by the power, take 1 off the power. Now we must set this equal to 0, and we're going to solve for x. Notice that I can factor a 3 out, and so I will get x squared minus 6x plus 8. And then I can continue to factor x minus 4, x minus 2. So this will give me two solutions: x equals 2 and x equals 4. These are two places where the gradient is equal to 0. So let me sketch what this might look like for you. Notice that at x equals 2 and x equals 4, we have turning points. And these are places where the gradient is 0. Now, can we determine what those coordinates are? Yes, you can. Very easily. All you need to do is find out what f of 2 is for this coordinate and f of 4 is for that coordinate. And so I'm going to just skip a bit of the maths here. 20, and then the coordinates of these stationary points are 2, 20 and 4, 16. What's really interesting is this point here is called a local maximum. And this point here is called a local minimum, because every point around it is higher than it, whereas the local maximum, every point around it is lower than it. Now, We can determine the nature of these stationary points using a little bit of maths. The trick is to find the second derivative of the function. So, the second derivative is where I'm differentiating this. So I get 6x minus 18. Let's check the 2 points. First off, let's check the value of the second derivative at 2. Is going to be 6 times 2 minus 18. It is equal to negative 6. If we check the 4, that is 6 times 4 minus 18. That's equal to 6. Notice that the local maximum has a negative second derivative and the local minimum has a positive second derivative. So we can identify whether it's a local maximum or a minimum based on the second derivative. If the second derivative at a point is greater than 0 or positive, then x1 is a local minimum. If the second derivative at that point is negative, then x1 is a local maximum. Remember, x1 has to be where the gradient is 0. For x1 such that f dash of x1 equals 0. So given that you've got a point where the gradient is 0, if the second derivative is positive, then it's a local minimum. If the second derivative is negative, then it's a local maximum. I hope that helps. All the best, Mr. Dharma.